we gaze up at the night sky, we see stars, planets, galaxies, an unfathomably vast cosmos. But what if this universe, as enormous as it seems, is just one of many? One bubble in a sea of countless others. One page in an infinite book. This is the idea behind the multiverse theory, a concept that challenges the very limits of imagination. It suggests that our universe may not be the only universe. Instead, there may be many universes, possibly infinite, each with its own laws, its own particles, and maybe even its own versions of you and me. Let's take a deep breath and begin our journey into the multiverse. Well, what is the universe? To understand the multiverse, we must first ask, what is a universe? A universe is everything we can observe. Space, time, matter, energy, and the physical laws that govern them. It includes every galaxy, every atom, every moment, from the Big Bang to now. As far as physics is concerned, our universe is the totality of existence. But physicists began to notice something odd. When they tried to explain how our universe works, why certain constants are the way they are, why matter exists at all, they realized that many aspects of reality seem strangely perfect for life. The values of forces like gravity, electromagnetism, and the mass of subatomic particles are just right. Even tiny changes would make life, or even atoms, impossible. Why? Is it luck? Design? Or are there other universes where things turned out differently? What is the multiverse theory? The multiverse theory proposes that our universe is not the only one, that it exists as one of many, perhaps infinite, universes. Each might have different laws of physics, different histories, and different outcomes. Think of it like this. You live in a house, your universe. But what if your house is one among billions, in a vast neighborhood, a cosmic suburb full of other houses, other universes? There isn't just one version of this idea, though. In fact, there are many different kinds of multiverse theories, some based in quantum mechanics, others in cosmology, and even in string theory. Let's explore some of the most fascinating ones. 1. The quantum multiverse. Many worlds. One of the earliest ideas of a multiverse comes from quantum physics, the strange science of the very small. In the 1950s, physicist Hugh Everett proposed the many worlds interpretation of quantum mechanics. It suggests that every time a quantum event can go more than one way, it does go every way. But instead of collapsing into one outcome, the universe splits into multiple timelines. For example, imagine you're flipping a coin. In one universe, it lands on heads. In another, tails. In yet another, it lands on its edge. This means that with every decision, every particle interaction, the universe branches, creating an unimaginable number of parallel realities. In one, you became a doctor. In another, a painter. In another, you never existed at all. These are not science fiction. They are serious interpretations of quantum theory, though unproven and possibly unprovable. Well, why? 2. The cosmic inflation multiverse. Another version of the multiverse comes from cosmic inflation, a theory about the early moments after the Big Bang. Physicist Alan Guth proposed that the universe underwent a rapid expansion, faster than the speed of light during its first fraction of a second. Wow. This inflation smoothed out the universe and gave rise to the structure we see today. But inflation might not be a one-time event. Oh. According to eternal inflation, inflation continues in some regions of space even today, bubbling off new universes like foam on the surface of boiling water. Each bubble universe could have different physical laws, shaped by the conditions of its own birth. We live in just one such bubble. Others could be wildly different, with different particles, forces, even numbers of dimensions. It's like an endless cosmic lottery. Some universes expand forever, some collapse, some never form stars or matter at all. Whoa. 3. The string theory landscape. In modern theoretical physics, another doorway to the multiverse comes from string theory. The idea that all particles are actually tiny vibrating strings too small to see. String theory requires extra dimensions, not just the 3 of space and 1 of time we experience, but maybe 10 or 11. And depending on how these extra dimensions are shaped or curled up, different versions of physics can emerge. This creates what's known as the string theory landscape, a mathematical space containing perhaps 10,500 possible universes, each with its own unique laws of nature. In this view, our universe is like a valley in a vast landscape, and there are countless other valleys, each corresponding to a different universe. Some theorists believe that only a tiny fraction of these universes could support life. And we happen to live in one that does, not because it was made for us, but because we could only arise in such a place. A simulated multiverse. Then there's a more controversial, mind-bending idea. What if our universe is not physical at all, but a simulation? Proposed by philosopher Nick Bostrom, the simulation hypothesis suggests that a sufficiently advanced civilization could simulate entire universes, including conscious beings inside powerful computers. If that's possible, then it might be likely. After all, simulated universes would be easier to create than real ones, and there could be many more of them. If true, we might be one of many simulated realities, a multiverse, not of space, but of code. Though impossible to prove right now, this idea raises deep questions about the nature of consciousness, reality, and what it means to exist. When can we test the multiverse? You might wonder, how do we know any of this is real? The truth is, we don't. Not yet. The multiverse is still a hypothesis, not a proven theory. In most cases, we can't observe other universes directly. They may lie beyond the cosmic horizon, too far away, or fundamentally disconnected from us. Some physicists believe certain patterns in the cosmic microwave background, the afterglow of the Big Bang, might hint at collisions with other universes. But so far, there is no clear evidence. Still, the multiverse isn't just science fiction. It's a natural consequence of serious theories, quantum mechanics, inflation, string theory. And in trying to understand the multiverse, we often uncover deeper insights into our own universe. What does the multiverse mean for us? Whether or not the multiverse exists, thinking about it changes how we see ourselves. It raises deep philosophical and existential questions. If there are infinite versions of me, what makes me? If everything that can happen does happen, does choice still matter? If our universe is just one of many, is it still special? Some find these ideas unsettling. The loss of uniqueness, the vastness of possibility. But others find wonder. All. One. A sense that the cosmos is richer, deeper, and more mysterious than we ever imagined. In a way, the multiverse reminds us how little we know, and how much there is left to explore. Conclusion. One universe, or many. So, does the multiverse exist? We don't know. We may never know. But in asking the question, we open ourselves to the unknown. Maybe we are alone. The only universe. The only consciousness in the void. Or maybe, just maybe, we are one voice in a grand cosmic chorus, part of a tapestry beyond comprehension. Whether the multiverse is real or not, one thing is certain. The human mind has the power to imagine, to dream of other worlds, other selves, and the infinite possibilities of existence. Thank you for listening.